Hey everyone, so now we are starting our next unit, which is on triangles. So we're going to be learning a lot about triangles. Actually, our next couple units are all different things about triangles. This first unit, after the first couple sections that we're going to do today, there's more of a focus on congruent triangles. But today we're going to do two sections, section 4.1 and 4.2. They're pretty quick, just like kind of introduction to triangle stuff, especially 4.1. It's super easy. So 4.1 is on classifying triangles. So in this chart right here, you can classify triangles by their sides. So by basically the number of congruent sides they have. So a scalene triangle is when none of the sides are the same. So 3 random values. Isosceles triangle is when there are two congruent sides. And an equilateral triangle is when all 3 sides are congruent. So that would be classifying a triangle by its sides. Classifying a triangle by its angles, we look at the measures of the angles. So an acute triangle is when all 3 angles are acute, meaning remember less than 90. A right triangle is when you have one right angle and then the other 2 are acute. An obtuse triangle is when you have one obtuse angle and then the other 2 are acute. And then equiangular is when all 3 angles are the same. Equilateral and equiangular go together. So if a triangle is equilateral, all the sides are the same, all the angles are automatically the same. So just real quick, some classifying. We'll use this triangle right here. We're going to classify these triangles by angles and by sides. So you name a triangle using its 3 vertices in any order using capital letters. So see, here's an example right here. There's a little triangle symbol and then the 3 capital letters. So triangle ABD would be this one right here. And so if you look at the sides are all marked as congruent, so that would make it equilateral. Since it's equilateral, all the sides are the same, all the angles are also the same. So it's equiangular. It would also be considered acute because if it's equiangular, we're going to learn in a couple of minutes, which we've already talked about this, that the 3 angles in a triangle add to 180. If all 3 are equal and they add to 180, then they're all 60, which are all acute. So you could also say that it's acute, but the better classification would be equiangular. Okay, next is EBD. So EBD, where's EBD? This one here. I can see that by sides, this and this are equal. So that's 2 sides that are equal. So that's called isosceles. One thing about isosceles triangles, which we'll talk about later on, is if 2 sides are the same, 2 angles are the same too. So it would be these 2, just so you know. And then to classify by angles, we can see that this one here appears to be obtuse. So we would say it's an obtuse triangle. Okay, next is BDC. BDC is this triangle here. Okay, look at that. This one is also same as letter B. See, 2 sides are the same, so it's isosceles. And again, this is bigger than 90 because this part is 90 and then this is a little more. So it's also obtuse. And the last one, ABC, is the big triangle, which has a 90-degree angle here, so it's right. That's by angles. I know I've been doing sides first for all the others, but that's okay. And then by sides, notice that this side has 1 mark, and that's only part of this side has 1 mark. So like this side is 2 of this one, and then this one doesn't really have anything. So we would say also too, I should say that it's a right triangle. So this hypotenuse is automatically longer than both of the other sides, the legs. So this one we would say is scalene because none of them are the same. So that's pretty much it for the first section. This is why we do 4.1 and 4.2 together, because 4.1 is just on classifying, which you guys learn that in a younger grade. So we don't really need to focus on that. This right here, so 4.2 technically is focused around the angles in a triangle. So this first theorem is the angle sum theorem, or triangle angle sum theorem. And it basically just says that the angles in a triangle add to 180, which we've talked about. We use those on the angle puzzles. So if we had something like example 1, we're finding the measure of angle T, you would simply just add 25 and 35, which is 60, and then subtract that from 180, which is 120. So measure of angle T, we would say, is 120 degrees. Okay, this got cut off. This is like a little mini kind of angle puzzle where we're given 90, 58, 108, and we have to find 1, 2, and 3. So first we're going to find angle 1 by adding 90 and 58 and then subtracting from 180. So 90 and 58 is 148, and then 180 minus 140, minus 148 would be 32. So that means this one, angle 1, is 32. Notice 1 and 2 are vertical, so 2 is also 32. And then now we can add 32 and 108 and subtract from 180, so that's 140, and then 180 minus 140 would be 40. That would be angle 3. So that's how you would find all of those. So that's angle sum theorem. The next theorem is called third angle theorem, and it says if two angles of one triangle are congruent to two angles of a second triangle, the third angles of the triangles are congruent. So if you look at this example here, since A is congruent to D and B is congruent to E, then by the third angle theorem, we could conclude that C and F are congruent. They would be forced to be congruent because D and E are congruent to A and B. So if you knew their measures and subtracted from 180, C would be forced to be congruent to F. So that's third angle theorem. The last theorem is called exterior angle theorem. But before we talk about the actual theorem, let's talk about what an exterior angle is. So an exterior angle, the definition is right here. It's an angle, basically it's on the outside of a triangle. So the definition that I have here is like the technical definition. But basically, if you extend one of the sides of a triangle, it makes an exterior angle with this adjacent side. So like I could extend this side and this would be an exterior angle. This is not an exterior angle. So it has to be adjacent to the side. So like at every corner, I could extend, that's an exterior angle. Or I could extend this. This is an exterior angle. So there's a lot of different possible exterior angles with every triangle. When you have an exterior angle, each one has a set of remote interior angles that kind of go with it. And we'll talk about the relationship in a second. So the remote interior angles are the angles inside the triangle that are not adjacent to the exterior angle. So angle 2 would not be a remote interior angle for angle 1. It would just be a linear pair with angle 1. But angle 3 and angle 4, those would be the remote interior angles for angle 1. So what the theorem says is that when you have remote interior angles and an exterior angle, the measures of the exterior one, so if you look down here where the theorem is, they add together to equal the exterior angle. So in this example here, whatever angle A is plus whatever angle B is would equal whatever the measure of angle 1 is. So if I gave you A and B and I said find 1, you could very easily find it. So here's an example just like that. So it says find the measure of angle 1. Well, angle 1 is an exterior angle. And these are remote interior angles. So all I have to do is just add 60 plus 80, and it gives me 140. And that is the measure of angle 1. Easy as that. Number 4, same idea, still using the theorem, but we just have to work backwards a little bit. So this is a remote interior angle, and this is a remote interior angle for this exterior angle, 78. So if you wanted to, you could write an equation. I know some of you like to write equations and do things algebraically. X plus 55 equals 78, and then you would subtract 55. Many of you, I'm sure, would just look at it and be like, oh, just subtract 55 from 78. However you do it, you get 23. You don't have to necessarily write an equation, though. Okay, and then the last example is kind of a combination of the angle sum theorem and exterior angle theorem. So notice that angle 1 is an exterior angle for 70 and 55. So if we add those two together to get 125, that would be angle 1. Angle 2 and 55 are vertical, so I can fill that in. And then notice that 55 plus measure of angle 3 equals 150, right? This one plus this one are remote interior angles, and they equal the outside one. Another way you could do it is you could fill in that one's 30, and then you could add 30 and 55 and subtract from 180. Either way, however you decide to do it, you get measure of angle 3 equals 95 degrees. And so that's it. Your practice today is mostly involving finding angle measures or writing equations to find x given a triangle with, if you have like an exterior angle situation, remember that the two inside ones add together to equal the outside one. Another option would be like ones like this, like example 1, for example. I keep saying, how many times can I say example? Example 1, for instance, if I gave you like if I gave you an algebraic expression for each of these angles, you would just add the 3 and set it equal to 180. So you'll see some of those too. So we're going to do some today and some tomorrow. All right, so that's it. If you have any questions, let me know. There is ACK Lab today from 1:05 to 1:55. I'll just be using my ACK Lab link, so feel free to hop on there if you have any questions. All right, have a great day.